Hello everybody, it's Mr. Slapka here, and I wanted to talk to you guys about section 10.5, which is about permutations and combinations. This is an extension of some more information that we learned in chapter 10, and it is going to be the first of 3 videos on this particular topic. So let's start off with some vocabulary. First 2 vocabulary terms, and the only 2 vocabulary terms we have is the terms permutation and combination. The terms sound similar to each other because they are similar to each other. Both a permutation and a combination are going to calculate the possible number of outcomes. The only difference between a permutation and a combination is whether order is important. A permutation means that order is important or order matters. Combination means that order does not matter. And so that is going to be the big difference between those 2. There are going to be some formulas for each of them as well that we're going to see further on down the page that you can see right down here. Before we get to those formulas, though, I wanted to remind you about something we had learned earlier in Chapter 10, which is something called a factorial. So, right here, what I have is I've got 2 very simple review problems about factorials. 3 factorial is not just simply 3, but rather 3 times 2 times 1. You take the number and you multiply it by every number that is smaller than that number all the way down to 1. 3 times 2 times 1 is going to multiply and give us 6. So the answer is much larger than you may have originally thought. Let's do the same thing for 9 factorial. So 9 factorial is going to be much longer. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so that takes a little bit. If possible, I'd like you to look on your calculator and see if you can find that button. There is always going to be a button that has that exclamation point. And so if you can find that button, you should be able to type this into your calculator instead of having to type this into your calculator, which would take much longer. Regardless of whatever technique you use, you should end up with a much bigger answer, which is going to be 362,880. Okay, now that we remember what our factorials are, let's see if we can take a look at our 2 formulas. So once again, remember, permutation means order matters, and combination means order does not matter. If you want to calculate these things, what you're going to do is you're going to be using some simple formulas that we see right here. The permutation one has a large capital P in it, and the combination one has a large capital C in it. They also have 2 smaller numbers, which we call subscript, because they're a little bit smaller and a little bit lower. Each of them are going to use an N and an R. Now, when you're looking at these guys right here, these are going to be replaced with actual numbers. And so the N number, or the first number, is going to go in the numerator and in the denominator. The second number, the R number, is only going to go in the denominator. Let's see if we can calculate some. So here's our very first one and our best example problem. So what we have right here is a very simple permutation for P. And that is going to be 5P3, or what some people will say is 5 choose 3. You'll understand why they use that word choose when we get on to some story problems in the second video. But for now, let's just calculate. So now we are going to treat that 5 as our N value and that 3 as our R value. So if we follow our formula right here, our N value is the first one, and so we're going to put a 5 factorial in the top. Then in the denominator, we're going to use that same 5 again, but we're going to pair it up with the 3. The 3 only gets used 1 time for a permutation. Okay, so now if we simplify this, 5 minus 3 down here in the denominator is in parentheses, so we want to start with that. So we are going to keep our 5 factorial in the numerator, and then now down here we're going to end up with a 2 factorial. Okay, now let's write it out. You could simply type this into your calculator, especially if you have your exclamation point buttons, but if you'd like to see what it looks like all together, I will now show you that. 5, 4, 3, 2, 1 for 5 factorial, and 2 times 1 for 2 factorial. Here's what's really happening. You might notice that some of the terms are showing up in both the numerator and the denominator, and those terms are going to cancel out to make 1s. That means that when you're calculating 5P3, all you're really doing is calculating 5 times 4 times 3. Notice that we started with the 5 and we used 3 digits in a row. That's what these 2 guys are going to correspond to. The value of this, 5 times 4 times 3, is going to be 60. Let's take a look at another one. So right here what I have is a couple others, and I'd like you to take a look at those. If you'd like to pause the video right now and practice a couple of them, that would be great. Here are a couple more. So 4P1, I'm going to put the 4 in the numerator and the denominator, and the 1 only goes in the denominator. You're going to do your subtraction first, and then you could either type this into your calculator using your factorial button, or you could write it out the long way. If you write it out the long way, what you're going to notice is because this denominator is very similar to the numerator, you have a lot more canceling and a lot more 1s. And so what's going to end up happening here is we're just going to do 4 times a bunch of 1s, and we're going to get an answer of 4 this time. Next one, let's take a look at this one. This one is 8p5. So we're going to have our 8 factorial on top and another 8 in the bottom, and then our 5 is going to go into the denominator as well. Now, 8 minus 5 is only 3. So when you do this one, you'll notice that there's a lot more on top and only a few terms in the bottom. And so there's not as many 1s that show up. You're going to have to calculate a lot more terms. Give it a count. See exactly how many terms we're going to calculate. We're starting here with the 8, which you can see here, and there's a grand total of 5 terms that we're going to calculate, which is what this number has to do with right there. When you calculate this one, you're going to end up with 6,720. Here are a couple more. These ones have some asterisks next to them, and that is because they're a bit special. You'll notice that this one has got a P0, and this one's got a double. It's got the 9 in the front and in the back. When you're using this P0 case, you'll notice that the numerator and denominator turn out to be identical. And that means everything in the numerator and denominator are going to cancel out to form 1s, and the whole problem is going to form a 1. If in the future you see this type of problem again, I hope that you can kind of skip over this work and follow the pattern. Anytime you get a P0, it will always be 1. Same kind of thing here. 9p9 means that down here in the denominator, we're going to end up with a 0 factorial. Now, please remember that 0 factorial is not actually equal to 0, but rather equal to 1. So what you actually end up with is just 9 factorial over 1. There's going to be a lot of numbers in the numerator, but there's going to be the exact same as just regular old 9 factorial. The value is large, but you could have skipped over all of the intense work and just typed in 9 factorial into your calculator and got your answer that way. Okay, now let's do one for a combination. Combination formula is right here. So the combination formula I want you to notice is very similar. Specifically, the first portion of the formula is exactly the same as the permutation part. The only difference is the combination part gets an extra piece in the denominator. Now, what I'd like you to do before we get started on that is I'd like you to think about that for a couple seconds. If there is more in the denominator than there was before, will our answers be larger or will they be smaller? Here's our first example problem right here. And so we have 7C4, or once again, what you could do is you could call it 7 choose 4. I'm going to start off with that 7, or our n value, on top. Then what's going to happen is that we're going to do our 7 minus 4 in the denominator, just like before. But the extra piece is we're going to have another 4 factorial in the denominator again. So now let's take a look. When we write this all out, that is going to end up being 7 factorial over 7 minus 4 is going to be 3 factorial, and then we'll also have 4 factorial down there. If we really extend everything, 7 factorial is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Down in the denominator, we are going to have our 3 times 2 times 1, and we're going to have our 4 factorial, which is going to be 4 times 3 times 2 times 1. Let's cancel some stuff. So now for canceling, what you'll notice is that we will have a couple of cancels that will turn into some 1s. But we will also have a couple of terms in the denominator that won't cancel. In the past, for our permutations, everything in the denominator either canceled out, and we only had to multiply numerator pieces. Over here, what's going to happen is that we're going to have numerator and denominator pieces, so you will have to divide. Now, I know sometimes when you divide, you get some decimals, and you might not feel very comfortable with that. Every time we do some of this division, we're going to get nice numbers. So you should be able to expect that. But you'll also find that they'll be smaller. 7C4 is only 35. That answer right there is quite a bit smaller than some of the larger answers that we saw with our permutations. You'll see that's true for all of our combinations. Here are a couple of more combinations, and I want you to notice that their answers are all relatively small. This one uses a 6 factorial in the numerator, and a good portion of it is going to cancel out, but because you are once again still dividing, your answer is relatively small. This one uses a 12 factorial in the numerator, but there is a ton of canceling that occurs. And because there is so much canceling, the answer is extremely small. In general, the combinations are going to have smaller answers, while the permutations have larger answers. Let's talk about some of our special cases. Here's another double. So we have 4C4, or what could be 4 choose 4. We have a 4 factorial in the numerator, we have a 4 minus 4 factorial in the denominator, and another 4 factorial in the denominator. What you'll notice is that almost everything cancels out, and when those things cancel out, remember they're building ones. So we end up with just a nice big fat 1 for this problem right here. Was that the same or different from when we had the permutation with the double trouble? Let's do another one. This time let's do 6 choose 0. So now we're going to do the choose 0 case. That means we're going to have our 6 factorial on the top, 6 minus 0 factorial in the denominator, and another 0 factorial. So when you expand all these out, you're going to end up with, once again, a lot of canceling. And every time we cancel, what we're doing is we're building another 1. And then you have to multiply all those 1s, and you still end up with 1. Is that the same, or is that different from what we had for our permutation when we chose 0? Last one. This is what I was, once again, hoping that you would get to. In the near future, what I'm hoping is that once you learn a couple of these simple patterns, you should be able to use them to answer these types of questions quickly. Because I see that I have a double, it doesn't matter that it's 12, I already know what to expect. The doubles are going to produce a 1 for me each time, and that's going to help speed up things when the problems get more complicated. Okay, this has been the first of 3 videos on section 10.5. I will have this loaded up on Google Classroom with those other 2, so make sure that you watch all 3 of them.